Welcome to class. So in this video, I am going to discuss inverse of matrix for two square matrix. So the two square matrix will be 2 by 2 matrix and 3 by 3 matrix. So I'll start with the inverse of 2 by 2 matrix. So for inverse of 2 by 2 matrix, if you have a matrix of this form, say the matrix A is equal to, for a 2 by 2, so let's take for example, let's say 5, 3, 2, minus 1. The inverse of a matrix. So the inverse of the matrix is meant to be, the symbol is raised to power minus 1 on top of the main matrix. So it's meant to be 1 over the determinant of the matrix, then times the adjoint of the matrix. So this is the formula for inverse of a matrix. So it is simply the same as adjoint of the matrix over the determinant of the matrix. So a better way of writing it is equals to adjoint of the matrix A over determinant. This line, I've said it before, that it means the determinant of the matrix. And you can decide to spell it out, maybe as DET or complete the spelling determinant. So this is the formula for inverse of matrix. So this implies that you have to find two different things. The first one is the adjoint of the matrix, and the second one is the determinant of the matrix. Of course, we have learned how to find the determinant of a 2 by 2 matrix in the recent videos I did. Okay, so let us first of all get the adjoint. Since the inverse of the matrix formula is adjoint of the matrix over determinant of the matrix, so let's first of all get the adjoint of the matrix A. So the adjoint of the matrix A, let me quickly explain the concept of adjoint. If you are to find the adjoint of a matrix, I'll open to another page. So if you have to find the adjoint of a matrix, you have to do something like this. If, for example, the matrix is A, B, C, D, then the adjoint of the matrix will simply be that you twist these two of them, you interchange them. That means you have D here and you have A here. Then you multiply the other two elements by minus. So this will become minus B and this will be minus C. So another example, if you have K, F, T, U, and you have to find the adjoint of this matrix, you twist these two of them, so you have that U will be here now, K will be here. Now, sorry, if this is minus F before, you need to multiply the minus F with minus, and that will become a positive F, a plus F, then this will be T. So that's how to go about it. So let me quickly do the explanation here now. So back to the main question. So this is the matrix we have, but we have to get the adjoint. So the adjoint of this matrix will simply be that I will twist the 5 and minus 1. So this will become minus 1 and 5 will now be here. So now I need to multiply these remaining two elements by minus. So this will be minus 3 and this will be minus 2. So this is the adjoint of the matrix. We have gotten the adjoint. The next thing is the determinant of the matrix. The determinant of the matrix, which is the same thing as this thing. Or, that's why I said or. Determinant of the matrix A, or this symbol is still determinant of the matrix A, will simply be, I've done it before, 5 times minus 1, 5 times minus 1, then minus 2 times 3, 2 times 3. So that is 5 times minus 1 is minus 5, and minus 2 times 3 is 6. So the determinant is minus 11. The determinant of the matrix is minus 11. Now we can now get the main answer. The main question is the inverse of the matrix. So the inverse of the matrix, remember, it is adjoint of the matrix over determinant of the matrix. So the adjoint of the matrix, we have gotten it as minus 1, minus 3, that's this place, minus 2 and 5. Now we have to divide them by 11, because the determinant of the matrix we have done it is 11, a negative 11. Now, this is what will happen. Anytime you are dividing a matrix by a number, what you do is each of the elements will be divided by that number. So look at this one, for example. I will have minus 1 over minus 11, minus 3 over minus 11, minus 2 over minus 11, 5 over minus 11. So the way it is here, our final answer, minus we cancel minus here. So I will have 1 over 11. Here minus we cancel minus, I have 3 over 11. Also, minus we cancel minus, I have 2 over 11. Here I will be left with minus 5 over 11. So this will be the final answer. Now, if there is a way you can reduce the fraction, you can reduce it to its lowest term, but these ones are not in the form that can be reduced. So this is the inverse of 2 by 2 matrix. It's as easy as this. And if, for example, you have a number, if, for example, this is maybe 2 here, 2 divided by 2 can just give you 1. It's not a must that they all remain fraction. All right, so that's the end of this 2 by 2, inverse of 2 by 2 matrix. So that will take us to 3 by 3. This is a 3 by 3 question on inverse of matrix. So we have seen the question. We are given the matrix K, and we can see the elements in it. Then we ask that if K is the matrix we have seen, then we ask to find K inverse. So like I said, K inverse is simply what's it called now? It's simply adjoint of K over the determinant of K. So we need to get the adjoint of K and the determinant of K. So let's work with the adjoint of K first. So the adjoint of K, I've discussed adjoint in the in one of the recent videos. So I said first have this in mind for adjoint. Your sign plus minus plus minus plus minus plus minus plus. This should be somewhere. Now you have to cover the rows and column of each element starting from 0. Cover this column. This is the 0 I'm talking about now. Cover the column of that 0. Cover the row of the 0. The element you are seeing will be 0, 1, 0, 0. You write it somewhere. 0, 1. The way they are, 0, 0. When you cover the column of minus 2 and the row of minus 2, you'll be having, when you cover it like this, you'll be having 3, 1, 1, 0. 3, 1, 1, 0. So that's 3, 1, 1, 0. When you cover that of 1, this one, the column of 1, and you cover the row of 1, you will be having 3, 0, 1, 0. That's 3, 0, 1, 0. So the same thing, you come and do this for 3 now. We are done with the first row. Now the 3 on, cover the row, cover the column, cover the row. You will have 0, 1, 0, 0. 0, 1, 0, 0. Do the same thing for 0. Cover the column of 0 and cover the row of 0. You have 0, 1, 1, 0. 0, 1, 1, 0. So do the same thing for all the elements one after the other. So when you repeat the same thing for this one, cover the column of this one and the row of this one, you will have, you can try it on your own also for you to be sure of how to do it for the certainty 1 and 0. That is when you cover this row and this, you have 0 minus 2, 1 and 0. So for the last row, when you cover 1, the row, the column and row of 1, you will have minus 2 and 1. You have 0 and 1. When you do it for the 0, cover the row and column, you have 0, 1, 3, 1, 0, 1, 3, 1. That's for that one. Then for the last number, which is 0, when you cover the row and the column of this 0, you have 0 minus 2, 3, 0, 0 minus 2, 3, 0. Now you have to find the determinant of each of these things. 0 times 0 will give you 0. 0 minus 0 times 0 is still 0. So the answer here is 0. 3 times 0 is 0. Minus 1 times 1 is 1. Here is minus 1. 3 times 0 is 0. 1 times 0 is 0. The answer here is 0. 0 times 0 is 0. 1 times 0 is 0. The answer here is also 0. 0 times 0 is 0. 1 times 1 is 1. That's 0 minus 1 is minus 1. 0 times 0 is 0. 1 times minus 2 is minus 2. Then minus 2. So that will be 0 plus 2. That's 2. 2 times minus 1 is minus 2. Minus 0 times 1 is 0. That's minus 2. 1 times 0 is 0. 0 minus 1 times 3 is minus 3. 1 times 3 is 3. So 0 minus 3 is minus 3. Then 0 times 0 is 0. Minus 3 times minus 2 is minus 6. So that's plus 6. That's normal 6. Plus 6 is the same thing as normal 6. So these are the values I am getting. Now the first value here is 0. The sign is positive. As far as it's 0 you got, 0 is neutral. So you just write a 0. Here that is minus 1. You multiply minus 1 by this minus. That will be a positive 1. Here that is 0. You don't need to add any sign. It's always neutral. 0 again is always neutral. Minus 1. Minus 1 and plus will give you a minus 1. 2, a positive 2 times minus will give you a minus 2. A negative 2 times plus will give you a negative 2 again. A negative 3 times minus will give you a positive 3. That's 3. And the last one, a positive 6 times plus will give you a 6. So this is the cofactor. Now for the adjoint, I said it in the video that adjoint is simply the transpose of the cofactor. So we have gotten the cofactor. This is the cofactor. This is the cofactor of the matrix. So the transpose of it is now going to be 0, 0, minus 2, 0, 0, minus 2. When you turn the column to row, so 1, 1 minus 1, 3, minus 1, 3, 0 minus 2, 6, 0 minus 2, 6. I hope you can see. So this is how it works. Then after this, this is the adjoint now. This is the adjoint. This is the adjoint of the matrix. We have gotten the adjoint of K. Now let's get to know the determinant. The determinant of K now. Please make sure you are following. Determinant of K, I've treated determinant of 3 by 3 matrix before, but we still need to do it. So for the determinants of K, we are going to introduce plus, minus, plus here. So because this is plus, I'll have 0. Then for 0, when you cover the row and column of 0, you'll be having, I'll be having just this element here, but let me just take it gradually. So when I cover here and I cover here, I'll have 0, 1, 1, 0, 0, 0, 1, 0, 0. Then minus, minus 2, minus 2. Now have this again. For 2, when I cover the row and column of 2, I'll have 3, 1, 1, 0, 3, 1, 1, 0. Then now plus 1, plus 1. Now when I cover the row and column of 1, I have 3, 0, 1, 0, 3, 0, 1, 0. Now just like this symbol implies, this symbol implies that we have to find determinant here. So but whatever this determinant is, by the time we multiply it with this 0, because we have to multiply it with the number, the coefficient of it. So by the time you multiply it with 0, this will turn 0. So there is no point stressing yourself. Yeah, even though the determinant here is 0, 0 times 0 is still 0. So minus times minus will give you a plus 2. Now 3 times 0 is 3. 3 times 0 is 3. Minus 1 times 3 times 0 is 0, sorry. Minus 1 times 1 is 1. Then plus 1. 3 times 0 is 0. 1 times 0 is 0. So 0. So here you have 2 open brackets minus 1. Because this 0 is no longer useful. Then you have plus 1 times 0. That's 0 also. So the answer is minus 2. The determinant here is minus 2. So now we can input this. Now that we know that the determinant of K is minus 2, we can now find our inverse. K inverse will be, remember, adjoint of K. The adjoint of K is this thing. So the adjoint of K, this adjoint of K, and the determinant is minus 2. So we'll be dividing each option by minus 2. So 0 divided by minus 2. 0 divided by anything is 0. 0 divided by minus 2 is 0. Minus 2 divided by minus 2 is 1. 1 divided by minus 2 is minus 1 minus half. Minus 1 divided by minus 2 is half. Then 3 divided by minus 2 is minus 3 over 2. Then 0 divided by minus 2 is still 0. Minus 2 divided by minus 2 is 1. 6 divided by minus 2 is minus 3. So this is the inverse of the matrix. Thank you.